Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your channel Chandan Physics. In this video, we are going to discuss the 555 timer as astable multivibrator. Let's begin. Multivibrator is an electronic circuit that rapidly switches due to positive feedback between multiple states. So, it is classified multivibrator as astable, monostable, bistable like this. But here we have to study how the 555 timer IC is used as a astable multivibrator. First of all, astable, the name indicates it is not stable. So, astable multivibrator is not considered stable in either of two possible states. A multivibrator has two states. So, any one of these states that the multivibrator is not stable. It continually switches from one of the potential states to the other, but does not require a clock pulse or other input in order to operate. That is why it is called as a free running multivibrator without any kind of clock pulse. It is always vibrate. Astable multivibrator is not stable in either of these two possible states. Now, what will be the circuit of astable multivibrator by taking 555 timer IC? This is the pin configuration of 555 timer IC. 8 pin, 1 ground, 2 trigger, output, reset, control, threshold, discharge, power. The astable mode of multivibration is achieved by adding two resistors R1 and R2 and a capacitor C to that of 555 timer IC. So, additional circuit R1, R2 and capacitor is connected to that of 555 timer IC in order to achieve astable multivibrator. So, here pin 1 is directly grounded, power VCC is supplied through that of pin 8, with which that pin 4 is shorted. Pin 2 and pin 6 are shorted and connected to ground through a capacitor C. Pin 7 is connected to that power supply through the resistor R1. The other resistor R2 is connected between pin 6 and pin 7. The pin 5 is grounded through a bypass capacitor having capacitance 0.01 microfarad. It is important to note that the circuit does not require any kind of external trigger signal. There will be no such trigger signal. Here we mention it, it does not require a clock pulse or other input in order to operate. So, there will be no such trigger signal. Therefore, trigger terminal pin number 2 is connected to that of threshold pin number 6, so that voltage across the capacitor is Vc. So, here the voltage across the capacitor will be Vc. Vc voltage across that capacitor. Let me discuss about the operation of that 555 timer IC. Basically, that operation we considered due to the charging and discharging of that capacitor. So, voltage across that capacitor is Vc. First operation, when the capacitor C, that is the capacitor that charges from 1/3 Vcc to 2/3 Vcc, 1/3 Vcc to 2/3 Vcc through the resistors R1 and R2. First it is charging from that potential to this potential through these resistors R1 and R2. The output remains high during this period. At that of case, the charging period is taken as T high. Why the output is high? Look here, during charging off period, charging off means capacitor is charged. The transistor T1, there will be two transistors in 555 timer IC, transistor 1 T1 and transistor 2 T2. Basically, transistors are used for switching purposes. Transistors or diodes are used in an electronic circuit for switching purpose. So, in that of case, two transistors are used, transistor 1 and transistor 2. When charging case, the transistor T1 is connected to discharge terminal. So, the transistor is off or low by using the RS flip flop. Therefore, the output is high and the discharge capacitor is cut off. Again, capacitor starts charging towards plus Vcc through that of resistor R1 and R2. And that charging is continued. During that, the threshold voltage rises with the charging of capacitor C. When that threshold exceeds that potential plus 2/3 Vcc, the comparator 1 changes its output state. This charges the states of flip flop so that the transistor T1 is high. Again that capacitor finds the path to discharge. So at case of discharging from plus 2 by 3 VCC to 1 by 3 VCC through that of resistor R2 only, the output remains low during that period. So in that of case, the discharging period we show as T low, time period of low case. At that of case, the comparator 2 changes its state, so that the state of flip flop again changes. Again the transistor T1 is off, and thus that process repeats itself without having permanent stability in any state. So one, in case of charging, that voltage change to this voltage. At that of case, charging period is T high, and again in case of discharging, that potential drop to this, and we achieve the time period of T low. This is all about how operations are held in case of 555 timer IC as Astable multivibrator. Here the applied signals, you draw the applied signals. Potential of the capacitor Vc, potential range as 1/3 VCC to 2 by 3 VCC, up, down, up and down. Same thing we achieve in that of output section. At output, this is time axis, so it is V output, voltage at output 1 0 1, like this. Here is the 0 1, this is the input towards that capacitor, this is the output we have. Let we understand that operation in case of charging. What is T high? T high is calculated, therefore the voltage across the capacitor C charging through a resistor, let R with the equivalent resistor having R1 and R2. So first I take it as resistor R. At any time at any instant of time, any instant of time t is given as, let Vc, voltage across that of capacitor, is Vcc, that is the power supply, to that of 1 minus e to the power minus t by Rc, that equation number 1. If we take the time period, if small m is the time taken by the capacitor to charge from 0 to 1 by 3 VCC, we have, so VC as 1/3 of VCC, instead of VC 1/3 of VCC is equal to VCC 1 minus e to the power, in place of t we substitute small m, minus m divided by RC, or VCC cancel out, 1 by 3 is equal to 1 minus e to the power minus m divided by RC, or e to the power minus m divided by RC is equal to 1 minus 1 by 3, 1 minus 1 by 3, that is equal to 2 by 3, or m is equal to, it is calculated as RC log base e of 3 by 2, log base e 3 by 2, its logarithmic value is 0.405 RC, that is equation number 2. This is small m, that is time taken by the capacitor to charge from 0 to 1 by 3 Vc, but we have to calculate the time period from 1 by 3 VCC to 2 by 3 VCC. Again, if we choose small m, small n is the time taken by the capacitor to charge from 0 to plus 2 by 3 VCC. We have, that is in place of VC, that is 2 by 3 VCC, VCC is equal to VCC 1 minus e to the power, in place of time small n minus n divided by RC, VCC cancelled out, so 2 by 3 is equal to 1 minus e to the power minus n by RC, or e to the power minus n by RC is equal to 1 minus 2 by 3, which is equal to 1 by 3. Now n as RC log of 3 base e, that value is equal to, n is equal to 1.0986 RC, that is equation number 3. Small m is the time required the capacitor to charge from 0 to 1 by 3 VCC. Here small n, time required to that of capacitor charge from 0 to plus 2 by 3 VCC, but our requirement is the time from 1 by 3 VCC to 2 by 3 VCC. Thus the charging period, T high is equal to n minus m, n 1.0986 RC minus m 0.405 RC, that is equal to 0.693 RC. But for that of charging, the charging path of that of resistor from R1 and R2, but resistance of the charging path is equal to R. First we take resistor R, so the charging path is R1 to R2, therefore R is equal to R1 plus R2. Therefore in place of R we substitute R1 plus R2, therefore so charging period T high is equal to 0.693 C. In place of R, that is R1 plus R2. Equation number 4. When that capacitor is charged. Another case, when capacitor is discharges. Second, capacitor is discharges from that potential to this potential, it is considered as T low through that of resistor R2. During that case we have to calculate it, what is T low. Therefore voltage across the capacitor C discharging through a resistor. Let that resistor first R at any instant of time, at any instant t is given by Vc is equal to 2 by 3 Vcc e to the power minus T by Rc. Equation number 5. Let us substitute Vc as 1 by 3 Vcc. Substituting Vc is equal to 1 by 3 Vcc. We have 1 by 3 Vcc is equal to 2 by 3 Vcc e to the power minus T by Rc, or Vcc cancel out, 3 cancel out, so it will be 1 by 2 to this side e to the power minus T by Rc, or T is equal to minus Rc log 1 by 2 of base e. That value is equal to 0.693 Rc. But we know the resistance of discharging path is R2, but resistance of discharging path is R2. So discharging period given as T low is equal to small t as 0.693 C in place of R, that is R2. So, the discharging period T low is calculated. This is T high for charging situation, for discharging situation, that is T low. So, the total time period of oscillation, thus total period of oscillation capital T is equal to T high plus T low, T high plus T low, or total time period of oscillation T is equal to T high 0.693 C R1 plus R2 C R1 plus R2 plus T low 0.693 C R2, or T is equal to 0.693 C R1 plus 2 R2 as the total time period of oscillation. So, frequency can be calculated. So, frequency f, which is reciprocal of time period 1 by t, or f is equal to 1 divided by 0.693 C R1 plus 2 R2, the frequency, time period and frequency of oscillation is evaluated. Equation number 7 and equation number 8. This is the total operation of that 555 timer IC as astable multivibrator for charging situation, the time period of oscillation, for discharging case, time period of oscillation, total time period of oscillation and frequency. So, when we compare that input to output, that is input voltage, here we obtain the output. So, when we compare it input to output, it can be easily understood by that of graph. If we plot a graph, this is plus, this is Vc, voltage at capacitors, 2 voltage scenario, plus 1 by 3 Vcc, another plus 2 by 3 Vcc. Next at output, here is the time period, So, at output V out, 2 states 0 and 1. Let me prefer the time periods. Here the input, high. At the tough case, it will be, the graph is and is the graphical view. This is V input, this is V output. Next, applications of astable multivibrator. It is used as square wave oscillator, free running ramp generator, pulse position modulator, skims trigger. In these cases, we use 555 timer IC as astable multivibrator. So, here with the help of this video lecture we understand the 555 timer as astable multivibrator. What is astable multivibrator? It is circuit. The additional circuit, 2 resistor and 1 capacitor is introduced to that of 555 timer IC to function as astable multivibrator. That is circuit for 555 timer as astable multivibrator. Potential input, potential output. This is the comparison. This is a comparison of capacitor voltage and output voltage, output states. That is the circuit. Operation based upon charging and discharging. For charging, when capacitor is charged, that potential to this potential, the time period is high, so T high is calculated. Next, at that of discharging situation, the potential drop from this to that, time period as T low is evaluated. Finally, total time period of oscillation, T low plus T high, then frequency, and the applications of astable multivibrator. So, with this useful and informative notes, let me wind up this session. Thank you.